Now let's look at the inverse Laplace transform. This is the symbol of the inverse Laplace transform of the Fs. You will get the Ft. So to evaluate the inverse Laplace transform, we also refer to the table of Laplace transform. However, if often happen that the function of s under the consideration does not match exactly in the form of Laplace transform Fs as given in the table. So we need to fix up the function by s or multiplying and dividing by an appropriate constant. So we will go through the example one by one. So this is the example. By referring to the table of Laplace transform, evaluate the inverse Laplace transform of the 8 over s. So 8 over s, we can take out the 8 as a constant. So 8 inverse Laplace 1 over s. So 1 over s, if you're using the table of Laplace transform, we can get back the equal to 1. So 8 times 1 is equal to 1. Then second question, inverse Laplace transform of 8 over s power of 3. Okay, so s power of 3, if you look at this one, we know that is a t power of n. We have t power of n equal to n factorial divided by sm plus 1. So you know that s power of 3 means that this is the n is referred to 2. Okay, so how do you get 8 divided by 2? You get 4. So 4, you take out the 4, inverse Laplace transform of 2 factorial and divide by s power of 3. So from here, we know that this is 4t squared. Okay, and then question number C, inverse Laplace transform of 2 over s plus 3. So for this question, we take out the 2 as it is a constant. So s minus 3. So this is what? This is referred to the shifting. Okay, 2. Okay, s minus 3, so it's an exponent negative 3t. Exponent negative 3t. If you refer to the text, you can notice that exponent at is equal to 1 over s minus a. Okay, now we move to another example. Inverse Laplace transform of 2 over 3s minus 7. Okay, so now the s here has a 3. We need to fix up the function of s. So this one is by dividing the constant 3. So to do this, I will have a divide by 3. So inverse Laplace transform, 2 divided by 3, and 3s also divided by 3, and 7 also divided by 3. So this 2 over 3, I can take it out as a constant. Then I left s minus 7 over 3. So again, this part I can change to exponent. So 2 over 3 exponent, then 7 over 3t. Okay. And then question E, inverse Laplace transform of 1 over s squared plus 64. This one, okay, so 64. Square root of 64 equal to root of 10 is 8, right? 8. So this means the inverse Laplace transform of s squared plus 8 squared. Okay. So what about the first one? So which one is suitable? Either is the cos or the sine. So let's check. Okay, this is the table of Laplace transform. If the sine is a over s squared plus a squared. If the cos is s over s squared plus a squared. So in our question, that is, we don't have any s on top on the numerator. So therefore, a is more suitable. We use the sine at. If we use the sine at, that must the a is 8. So we have the 8 here. Okay, to fulfill the sine at format. But this 8 is the extra. In the question, we don't have this value. So we need to divide by 8 so that you can eliminate the value. So I divide by 1 over 8. So this will equivalent to 1 over 8 sine 8t. And then question number F. Inverse Laplace transform of 8 over s squared minus 8. So we need to find out the square root of 8 here. So equivalent inverse Laplace. Okay, I have the s squared minus the square root of 8. Okay, so how to do? We need to square root, and 8 it cannot be square root. So what I do is square root and square. So I will get back the same value. Okay, so in order for this, let's check what do we have in the table of Laplace transform. Since the question just now is s squared minus 8, right? So minus is more suitable for have the sinh 80. So for the sinh 80, we still need the square root of 8, but this is not the original value, so I need to cancel out by dividing the square root. Okay, we cannot divide because we still have the value of 8, so we multiply with the square root of 8, so that square root of 8 multiply with square root of 8, so we will get back the 8. So we multiply with square root of 8. So this, when we simplify, I will get the square root of 8 multiply with sinh square root of 8t. Okay, understand? Okay, now we move to another question. G inverse Laplace transform of 1 over 8 s squared plus 64. So for this question, the function of s here is not 1, is 8. So we need to divide by 8. So to get the s squared plus 8. So I rewrite it into 8 s squared plus 8. So 1 over 8 as a constant. Then inverse Laplace. Okay, I get s squared plus square root of 8 and then square. So this one, like previous example, for the numerator still the square root of 8. But this square root of 8 is an extra, so we need to cancel out by divide the square root of 8. So the answer is 1 over 8 times with 1 over square root of 8 sine square root of 8t. And next question is the inverse Laplace transform of the 4s squared plus 25. So again, if you look at here, the function of the s here is not matched with the format of the Laplace transform in the table. So therefore, we need to divide. Okay, so divide with 4. Okay, inverse Laplace transform of the 4s divided by 4, and 4s squared divided by 4 also, plus 25 divided by 4. So this will equivalent to s over s squared plus, okay, so usually you will have the square. So you square root of the 25 over s, you get 5 over 2 square. So this is equivalent to, okay, if you check with the table, so this is referred to the cos 80, you will have the s over s squared plus a squared. Therefore, I put here as cos 5 over 2t. Then last example is the inverse Laplace transform of the 3 over 9s squared plus 4. Again, this function of s is not fulfill the format of Laplace transform table, so we need to divide by 9. Divide by 9, so we get inverse Laplace transform 3 over 9, 9s squared over 9 plus 4 over 9. So 3 over 9 as a constant, and then we have s squared plus with square root of 4 over 9, we get 2 over 3 squared. And this one we get 1 over 3. Okay, inverse Laplace with, okay, the denominator we have s squared plus 2 over 3 squared. So for the sign here, the numerator also 2 over 3. But this value is not belong to this question. This is an extra. So we need to divide with the 2 over 3. So this one cancel out. We get 1 over 2 sine 2 over 3t. Next, I would like to share with you how to find the inverse Laplace transform using the linearity property. Now let's look at the example 4.9. By applying the linearity property of inverse Laplace transform, evaluate the inverse Laplace transform of 10 over s power 4 plus 1 over s power 5. First of all, we write it separately. Okay, so 10 over s power 4 plus inverse 1 over s power of 5. So this will equivalent to, so 10 here is a constant. We can take it out. And, okay, if you look at here, s power of 4, we know that that is from the table of Laplace transform, t power of n equal to n factorial divided by s power of n plus 1. So if you look at here is s power of 4 means that the n is 3. Okay, this n is 3. So I will have a 3 factorial divided by s power of 4 plus, okay, so this 3 factorial. So this 3 factorial is not belong to original question, so we need to cancel it out by divide the 3 factorial. And then plus with, okay, in the question is s 1 over s power of 5. If you base on this one, s power of 5 means that it is a 4 factorial. So it's a 4 factorial. So it is 4 divided by s power of 5. So this one, the value of 4 factorial also not belong to this question. So we need to cancel it out by dividing it into 4 factorial. Okay, then we can simplify 10 divided by 3 factorial. 3 factorial means the value is 6. Okay, so this inverse Laplace we can get t power of 3 plus 1 over 4 factorial. So 4 times 3 times 2 times 1 we can get 1 over 24. And then this inverse Laplace transform of this value we can get t power of 4. Okay, so I can simplify 5 over 3 t power of 3 plus 1 over 4 t power of 4. Next question is inverse Laplace transform of 2s plus 3 divided by 3s squared plus 4. Second question, we also can split it into inverse Laplace transform of 2s divided by 3s squared plus 4. And then plus with inverse Laplace transform of 3 over 3s squared plus 4. We need to divide by 3 because the s here is not 1, it's a 3s, so we need to divide by 3. So therefore, after we divide by 3, we have a 3s divided by 3 3s squared divided by 3 and 4 also divided by 3 plus with, okay, this side also divided by 3, okay, because 3s squared, so we divide by 3 plus with 4 over 3. So here 2 over 3 is a constant, so we take it out, 2 over 3 inverse Laplace transform, and we left the s divided by s squared plus 4 over 3. Plus with inverse Laplace transform, 3 divided by 3 we get 1, and then we get s squared plus 4 over 3. Next, okay, if you look at here, we know that this is operation of plus and this is s, so most probably it's a cos. Okay, cos. So inverse Laplace transform, s over s squared plus 4 over 3 square root and square. So we need to fulfill the format of the cos. And then plus with, okay, inverse Laplace. Okay, this one is square, s squared plus square root of 4 over 3 and then square. So this one is not s, so most probably is the sign. So when it's sign, this one should be follow. So this one also square root of 4 over 3. As you know, 4 over 3 is not belong to this question, so we need to divide it by square root 4 over 3 too. So we divide it. And then we can simplify 2 over 3. Okay, this one is a cos. And this part we can simplify it into 1 over square root 4 over 3. So this is equivalent to 1 over 2 over square root of 3. And this will equivalent to square root of 3 divided by 2. So cos 2, this will equivalent to 2 over 3 cos. Okay, with square root of 4 over 3, that means it's 2 divided by square root of 3t. And then plus with 1 over square root of 4 over 3, this will equivalent to square root of 3 over 2 sine 2 over square root of 3t. Okay, this one we can get it from 1 over square root of 4 over 3 equivalent to 1 over square root of 4, you get 2 divided by square root of 3. Okay, so this is equivalent to square root of 2 over 3. At square root of 3 over 2. So this is basically how to apply the linearity property in the inverse Laplace transform. Next is the inverse Laplace transform using the first shift theorems. If inverse Laplace transform of the s minus a, you will get exponent at ft. Okay, or we can rewrite into exponent at and inverse Laplace transform of the fs. Okay, let's look at the example. By applying the first shift theorems of the inverse Laplace transform, evaluate this inverse Laplace transform of the 3 over 2 s minus 4 squared. To do this, we need to take out the constant. 3 over 2 is a constant, so we take out the 3 over 2, and then we left 1 over s minus 4 squared. Okay, so s minus 4, where is this? Okay, if you check exponent at, okay, this is from the Laplace transform table, is equal to, exponent at is equal to 1 over s minus a. So if you compare the s minus 4, so this means the a is equal to 4. So this is equivalent to exponent 4t. And then we keep simplifying, and then we have inverse transform of the 1 over s squared. So 1 over s squared, if you refer again the Laplace transform table, you will get t power of n equal to n factorial divided by s n plus 1. So this is 3 over 2 exponent 4t, and Laplace transform of this part, I will get t only. Okay, so that's all for this question. Then we move to next example. That is inverse Laplace transform of the 3 over s plus 4 power of 4. In this question, we also know that s plus 4 is something to do with exponent at equal to 1 over s minus 8. So in this case, the a is equal to how many? Do you know? Is minus 4. Okay, so I write down here exponent negative 4t. So we still left 3 over s power of 4. Okay, so this part already changed to here. So we left 3 over s power of 4. Okay, next. Okay, when you look at this one, okay, s power of 4, we know that is refer to the t power of n factorial divided by s power of n plus 1. So when s power of 4 means the n equal to 3 factorial. Okay, 3 factorial. So this 3 is a constant, so I take it out also, 3. And then, so for the t power of n, so I have 3 factorial divided by s power of 4. For, as you know, this 3 factorial is not belong to this question. Okay, so we must cancel it out by divide the 3 factorial. So I divide with 3 factorial. So I simplify it. 3 factorial refer to 3 times 2 times 1, and then multiply with t power of 3. Okay, t power of 3. So I can cancel out the 3 here. So I left t power of 3 exponent minus 4t divided by 2. Next, we move to next question. Inverse Laplace transform of the 12s divided by s minus 1 power of 4. In this question, 12 is a constant, and this part is the t power of is a shifting exponent of something, and power of 4 is about t power of n. Okay, so it's quite complicated. What if we multiply with the s minus 1 to do the operation and make it easier? Okay, now I do it like this. Inverse Laplace transform, go to 12, and then s minus 1 divided by s minus 1 power of 4. Okay, I multiply with the same value s minus 1. Okay, so when you multiply this one, multiply in, so I get 12s minus 12. But in the question, it's only 12s. So it means that the negative 12 is an extra. So what you need to do is I have to cancel out by add the 12. By add in the 12 to cancel out the extra negative 12. So since this is the operation of plus, I need to separate it. Okay, split it into 2. So inverse Laplace transform of the 12s minus 1 divided by s minus 1 power of 4 plus with inverse Laplace transform of 12 divided by s minus 1 power of 4. So this 12 actually is a constant, so I can take it out. So 12 inverse Laplace transform s minus 1, then s minus 1 power of 4, and then plus with 12 again is a constant, I take it out, and then inverse Laplace transform of 1 over s minus 1 power of 4. Okay, then what you can do, we can simplify it because this is the same, so I can cancel out. So I can cancel out, this one equal to 3. So remain 1 over s minus 1 power of 3 plus 12 Okay, for this part, s minus 1, okay, we change to the exponent. So, exponent, the a is 1, so exponent t, and then inverse Laplace 1 over s power of 4. Okay, then next, this part we also can change. So 12 exponent t inverse Laplace, we still remain s power of 3 plus 12 exponent t. Okay, this one we can change to t power of n. So n is equal to 3. Okay, so inverse Laplace 1 over, oh sorry, is not 1, is a 3. 3 factorial divided by s power of 4. Okay, so again, this one is the extra. Okay, this one is the extra. So we need to cancel out by dividing into the 3 factorial. And then next, we have a 12 exponent t. So this one, we can change it also to t power of n, since the s power of 3, we know that is a n equal to 2. Okay, 2 factorial. So we need to cancel out the 2 factorial also. So I put 1 over 2 factorial. And then this one is 2 factorial divided by s power of 3. Plus with 12 exponent t divided by 6. Because 3 times 2 times 1 is 6. And then this part is a t power of 3. Then we simplify it into 12 divided by 2 exponent t, and then this part is a t power of 2, okay, plus with this one is 2 exponent t and t power of 3. So we can simplify again into, this one is 6 exponent t power of 2 plus 2 exponent t power of 3. Okay, or I can factorize it into 6t squared plus 2t power of 3 exponent t. Okay, that's all for this question. Do you understand now how to do the inverse Laplace transform? The last question is inverse Laplace transform of 1 over 3s divided by s plus 3 squared plus 2. This question is quite similar to the previous question, in which this 1 over 3s, 1 over 3 is a constant, and s we will multiply with s plus 3. Okay, we'll multiply with s plus 3. So we will obtain inverse 1 over 3 s plus 3. Okay, so 1 over s plus 3, if we multiply in, we will get s plus 3, 1 or s over 3 plus 1. So this plus 1, this positive 1 is extra. We need to cancel out by minus 1. Okay, so s plus 3 squared plus 2. Alright, so from here, we take out the 1 over 3, and then we left s plus 3, and then s plus 3 squared plus 2. So we split into 2 because it's the operation of minus. Okay, so we minus with inverse Laplace 1 over s plus 3 squared plus 2. So for this part, okay, 1 over 3. And then next is this part. So for this part, I will have the inverse Laplace transform of this whole thing. Okay, s plus 3 over s plus 3 squared plus 2. So this whole thing, we will obtain this, and this will get exponent negative 3t. And then inverse Laplace transform of s over s squared plus 2. Okay, whereas for this part, we will obtain exponent negative 3t, and then inverse Laplace transform 1 over s squared plus 2 squared. So I write it down here. This is 1 over 3, and then exponent negative 3t inverse Laplace s over s squared plus 2 minus exponent 3t minus exponent 3t inverse 1 over s squared plus 2. There's a mistake here. This is 2 only. Okay, and then next equal to 1 over 3 exponent negative 3t, and then for this part we can get a cos. So we can write down like this: s over s squared plus square root of 2 and then square minus exponent negative 3t and then inverse. Okay, this one we can get in terms of sign. So you need a square root of 2 divided by s squared plus square root of 2 squared. So this is the extra value, so you need to divide with the square root of 2. Then finally we can get 1 over 3 exponent negative 3t cos square root of 2t minus exponent negative 3t square root divided by square root of 2 sine square root of 2t. In order to familiarize the inverse Laplace transform, so I give you another example again to show you how to find the inverse Laplace transform and give you a clear picture and more understanding on how to use the first shift theorems to find the inverse Laplace transform. This question is quite similar to the previous example. Okay, this has a 3s plus 5 divided by s squared minus 4s. So we can split into 2 because it's an operation of plus. So I write in this way. I take out the 3, 3 for the inverse Laplace transform of s over s squared minus 4s. And then plus with 5 inverse Laplace transform of 1 over s squared minus 4s. Okay, I split into 2 because it's an operation of plus. And then I take out, since it's a s squared minus 4s, so I take out the s so that it can cancel with the s at the numerator here. So I have 3 inverse Laplace s over s minus 4 plus 5 inverse Laplace 1 over s squared minus 4s, okay, plus with, so in order to do this 4s, so if we want to do the factorize it, so s minus 4s, so what you can guess? For example, s minus 2 square. So from here you can get s squared minus 4s, okay, plus with 4. Am I right? Okay, so we only, the question only given the first part. So if we want to factorize it like this, we need in this form, because we need in this form, and the question only given this one. So we don't want this value is extra, so we need to cancel out. So we need to cancel out. So we need to plus with negative 2 square is a positive, so minus 4 is so we will cancel out. Therefore, we can simplify again, and this part is the shifting part. So 3 exponent 4t inverse Laplace transform. When this one cancel out, we left 1 over s plus 5 inverse Laplace 1 over s minus 2. Okay, as I mentioned to you here, s minus 2 square minus 4. And then next is 3 exponent 4t Okay, and this part 1 over s, if you refer to the Laplace transform table, you will get 1. And then plus with 5 exponent, so this part you'll get exponent 2t inverse Laplace, and then you get 1 over s squared minus 2 squared. Because this part we already transferred to here, so we just left s squared minus 2 squared is referred to 2 power of 2. Then we simplify again into 3 exponent 4t plus 5 exponent 2t. If in this form, mostly if a negative, this is for the cos or sinh. And then we don't have the s here, so mostly is the sinh. So I have the inverse Laplace transform of here is 2, so 2 over s squared minus 2 squared. So 2 is an extra, so 2 is an extra, so I need to divide with 2. So at the end I get 3 exponent 4t plus 5 over 2 exponent 2t sinh 2t. Okay? To do this question, we need to factorize this one. Okay, we need to factorize this one. So 2s squared minus 8s plus 16, which is we take out the 2, we left s squared minus 4s plus 8. Okay, this is question number 1. So if we want to take this s minus 2 squared, this is equivalent to s squared minus 4s plus 4, which is can cover the first half part. Okay, so if we compare with 1, this means that we have 2s squared minus 4s plus 4. Okay, if we assume this one plus 4, means that we still need to minus 4. Okay, because this one is an extra. So we need minus 4 plus 8. This 8 is the original. Okay, this 8 is the original. This means that from the question is given like this. But if we want to factorize it into this one, this s minus 2 squared will obtain s squared minus 4s plus 4. Okay, this the first half part exactly match the question given. But this 4 is an extra. So we need to minus 4. Okay, we need to minus 4 and plus back the 8. Alright. So this will equivalent to 2s minus 2 square plus 4, because this part already changed to here. And then minus 4 plus 8 is equal to positive 4. So now I rewrite it again. So you get inverse Laplace transform of 2s minus 3 divided by 2s minus 2 squared plus 4. So this will equivalent to 1 over 2 inverse Laplace transform. So I take out the 1 over 2 here. So 1 over 2 inverse Laplace transform of 2. Okay. Then s I multiply with s minus 2. Okay. So s minus 2. Okay. When you multiply s minus 2, so you get 2s minus 4. But in the question is minus 3. So what you need to do? You need to plus 1 to get back the same value as given in the question. So the denominator is still the same, s minus 2 squared plus 4. Then I simplify again, 1 over 2, I take out the 1 over 2. So I split because the operation of positive, a plus, so I split into 2. So inverse Laplace transform of s minus 2. Okay, so I take out the 2 here again, it's a constant, and then s minus 2 divided by s minus 2 square plus 4 plus with inverse Laplace transform of 1 over s minus 2 square plus 4. Then this will equal to 1 over 2. 2. So this part and this part. Okay, maybe I write in a different color. This and this, you will obtain exponent 2t. And then inverse Laplace transform of s divided by s squared plus 2 squared. Alright. Then next one is this part, you will obtain exponent 2t, the inverse Laplace transform of 1 over s squared plus 2 squared. So this one you can cancel out. Okay, so 1 over 2, 2 exponent 2t cos. So this part I will obtain cos 2t plus with inverse Laplace transform of sin. So this part is a plus, so I can have the sine for the sine. So for the sine, format of sine is 2 over s squared plus 2 squared. But this 2 is an extra, so I need to divide by 2. And I have the exponent 2t. Okay. And this will equivalent to exponent 2t cos 2t plus with this one multiply with this one, so you have 1 over exponent 2t. And then this part I will get sine 2t. Okay, do you understand now? I hope you can understand and enjoy the YouTube video. If you like my video, you can like my YouTube video. Thank you very much.